folks, I'm going to talk to you a little bit today about wave types of phenomenon, and for the purposes of the next video we're going to be talking about electromagnetic waves. So there's some properties about waves that are very important that we have to understand before we start talking about light and radiation. So here's kind of a picture that kind of represents some sort of waveform moving along. So this could be like a water wave, or it can also represent sound waves, or like we're going to talk about in the next video, electromagnetic waves. And some important properties of waves that we're going to need to know about. Well, one, you got to picture this entire waveform moving to the right with some speed. Right? So this thing's moving to the right with a speed v. A very important property of waves is the distance between any two successive points on the wave, and that's referred to as wavelength. So I wrote here on the board here, one wavelength is equal to this distance. Now, for whatever reason, I'm not really sure why, this symbol right here, this is the Greek letter lambda, and it's usually used to represent wavelength in about every textbook I've ever seen. So that symbol represents the distance between here and here, or between here and here, or from here to here. It's the distance between any 2 points on the wave that are the same point on the wave, like here to here, one wavelength, right? Or here to here, and so forth. Okay? Waves also have a property called frequency. Because imagine these waves hitting the wall over on the right. And conceivably, a whole bunch of them may hit that wall in any given time frame. So the frequency is what describes that. Frequency is defined as the number of cycles per second. You can define frequency for any oscillating type of phenomenon or any phenomenon that's repeating itself. So frequency is just how many cycles occur per unit time. Another important property is the period. Now the period is the number of seconds that it takes for one cycle to occur. So it's the number of seconds per cycle. If you look at these two relationships, it's very clear to see how they're related. This is the reciprocal of this thing. Right? So once you know the frequency, basically you know the period. So I went through a quick little example here. If we have some sort of oscillating phenomenon that occurs 50 times or goes through 50 cycles in 10 seconds, then the frequency would be 50 cycles over 10 seconds, which is equal to 5 cycles per second. Now the term cycle really is not a physics unit. It's not a mass or a length or a time, so it's usually not written in the units. So the units here would just be 1 over seconds. Right? And that's what the unit is, a per second. And a per second has its own special name. That's called a hertz. So we would say the frequency of this phenomenon is 5 hertz. The period of this phenomenon then would be 1/5 of a second. Because if it's 55 cycles per second, then the time per second would be 1 second. Okay? So we got frequency, which describes the number of cycles per second for the wavefront. We have wavelength, which is the distance between any two successive points. And remember that the wave is moving to the right with some speed v. This is an important relationship for wave types of phenomena. The velocity of the wave, or the speed in which it's moving at, is always equal to the frequency times the wavelength. Because if you kind of look at this ends up being a distance over a time. Because remember, frequency is the number of cycles per second. The wavelength is the distance per cycle. So, or the distance per wave. So by the time you take number of waves times the distance per wave, the top is the total distance that the wave has traveled, divided by the time, which is in the bottom from this term. So you end up with a speed. So these are very important properties about waves. It's important that you know what these properties are. Waves travel at some speed, v. They have a wavelength, which is the distance between any two successive points on the wave. So for example, in this picture, here to here, or maybe here to here, or here to here. And then these waves have a frequency, the number of cycles per second, which would typically be measured in hertz. And they have a period, which is the number of seconds per cycle. It's basically the reciprocal of the frequency. So there's a little bit about waves, and now I'm going to make a video to talk about how these relate to electromagnetic waves.